go, class. All right, so we're going to do 3.5 overlapping triangles. Do you have your highlighters? Do you have your colored pencils or your different colored pens? If not, get those out. You're going to want to have them today to help you to separate these triangles. 3.5 isn't really anything new. It's just that now the pictures are a little bit more complicated. Rather than the triangles being separated, now the triangles are on top of one another. Throughout this video, I'm expecting that you're pausing the video when you need to and you're restarting it. So like maybe right now would be a really good time for you to pause the video. No, literally, like stop the video and then write down the problem. Okay, I'll give you 2 seconds to do that. All right, you're back. Okay, so the key is to try and separate out the 2 triangles. They're overlapping triangles. So just briefly looking at this picture, okay, I'm probably not proving this triangle and this triangle are congruent because those are not overlapping triangles. Just trying to give you a hint of what to be looking for. So instead, like try and look to see which ones that you have the most information on, and then try to prove those 2 triangles are congruent. So with this one, statements, reasons. 1, DB congruent to AC. Given. So let me mark those 2 congruent. Now they're kind of on top of each other, so I'm looking to see this one is congruent to this one over here. And then AD and BC are congruent. So this piece and this piece are congruent to each other. Now look and see which triangles that you've got a lot of information on. Okay? If I look at those first 2 triangles I highlighted, DEA and CEB, yeah, maybe I could prove those 2 are congruent to each other. Actually, I don't think I can now that I look at it. All I have on those 2 little triangles, all I have is just side DA and side BC. The big segments from D all the way to B, that's not on that little triangle. So I'm looking at probably the 2 triangles. Let me grab a different color here. I'm thinking this triangle, DAB, and I'm going to redraw that over here. I suggest you do the same thing, which means do it. And on that triangle, I've got this side marked, so I'm going to put a marking there. And I've also got the side from D to B marked. So I'm going to put a marking on that one as well. The other triangle I think that I'm going to be, that's overlapping that I'm probably proving congruent to that one, is this one, triangle CAB. So I'm going to redraw that triangle, CAB. And on that one, I've got this side marked, so I'm going to mark that one. And I've also got this entire segment marked. So, oh, I forgot to write that down in my proof, didn't I? So in order to prove these 2 triangles are congruent, either I need another side, or I need to somehow prove angle C and angle D are congruent to each other for the included angle. Now looking at this, I'm thinking probably not proving C and D are congruent right now because that's what I'm ultimately getting at. So I probably need these 2 triangles are congruent, and then I'll use the CPCTC to help me prove that those 2 angles are congruent to each other. So look and see, what do these 2 triangles have in common? There's a segment or an angle that they both have the exact same of. If you look back to the original picture, they both share this segment right here, AB. So I could use the reflexive property to say that AB is congruent to BA. They're the one and the same. By the reflexive property. Then I can say these 2 triangles are congruent. Make sure you say them in the correct order. If I call the first one ADB, it should be a D. The second one would have to be called BCA. By side, side, side. So now I've spent a ton of time proving these 2 triangles are congruent. And now I could say by CPCTC that this angle D and this angle C would be congruent to each other. And then that's it on that one. We're done. So the tricky thing here is trying to see which pair of triangles you have congruent. It seemed pretty obvious on this one because there wasn't a lot of options. But you'll see like on this next one, there's a lot of different triangle options. Okay, so now might be a good time to pause the video and mark that down, write down that the picture and the givens and the proof. So knowing that these are altitudes, that means I've got some right angles. I'm not really sure yet which triangles I'm going to be going for. Like if I try, maybe I'll just go ahead and write down my other given right now. Even though I usually wait, I'm going to go and just put it down for this problem. BE and DC are congruent to each other. So this piece, same size as that piece. Look at the options you have for triangles. I could try going for this triangle and this triangle. But the only thing is that, well, on those two triangles, BE is not a full length, is like longer than any one of the sides on those triangles. BE is not a side of one of those triangles. It's like B to like this point right here in the middle where they cross is not the length from B to E. So I'm probably not going for those ones, plus this section is called overlapping triangles. Those ones aren't overlapping, so probably not those ones. Let's try something else. What if I try and go for this bottom triangle and trying to prove that one is congruent to this bottom triangle? At least on those ones, I'm using the fact that this whole piece is the same size as this whole piece is. At least those are segments on those triangles. So then my next question is what are we trying to prove? Which triangles would have a CP-CTC that would include BE and DC? The two triangles I just highlighted there at the bottom, if I can prove those two congruent, then by CP-CTC, I could definitely say that BE and DC are congruent to each other. Okay? So I'm just kind of tucking that in the back of my mind for, okay, so I've got a lot of stuff marked on those ones. What would CP-CTC on those two triangles get me where I'm trying to go? Here's another possibility that maybe you didn't see before. What about trying to prove these two triangles on the top side are congruent to each other? Looking at those, remember what we were given? We were given that this piece was congruent to this piece. That's another pair of segments that are congruent on those upper triangles. And if I prove those upper triangles congruent to each other, they still have BE and DC as sides on them. So then I could use a CP-CTC on those two and come up with those two sides are congruent. So this one I have two different options. I can either do the bottom two triangles or I can do these top two triangles. Either way, I think we're going to be able to get there. Being I have these two top triangles highlighted, I'm going to go ahead and use those ones. But I'm going to redraw them. So that's what I've got. All I have is one side. Well, that's not really enough to prove two triangles are congruent to each other. But we haven't really used this first thing about the altitudes, that first given. So if those are altitudes, like, yes, I do have a whole bunch of right angles, but only a couple of them are actually helpful for us. If I'm trying to prove that these two triangles are congruent to each other, knowing that CD is an altitude, I probably want to say that angle is a right angle. I probably want to say that angle right there is a right angle. Knowing that BE is an altitude, I probably want to say that angle is a right angle, so that way I have a right angle that's actually on my triangle. Yes, I could say this angle at the bottom is a right angle, but that doesn't really give me any right angles on my picture, on my triangles I'm trying to go for. If I was trying to go for the bottom two triangles, you better believe it, I would try and go for that angle, and I would say this angle down here are also right angles. But since I'm going for the top two triangles now, I'm not going to say those ones. All right, so let's add that to our proof. Angle. Can I call that angle D an angle D? Nope. Okay, look back to the original picture. There's a lot of angles that could be considered angle D or angle E because there's a lot of different angles that have those as vertices. So I got to call it angle ADC and angle AEB are right angles. Altitude makes right angles. If I'm going to prove these two triangles are congruent to each other, I'm going to need to say that those angles are congruent. I'm probably going to need them. So I'm going to say those angles are congruent. Angle ADC congruent to angle AEB, right angles are congruent. Then I either need another side or I need another angle. I need something else to help me prove that these two triangles are congruent to each other. I'm scanning through this and, oh man, did I really do that this whole time? Shoot, I sure did. We were not given these two are congruent to each other, were we? No, we were given the top two were congruent. We were given this one and this one were congruent. So my whole spiel about using the bottom two triangles, I couldn't have used the bottom two triangles if I wanted to, because I didn't even have anything marked on those two triangles. If I did have BE and DC were congruent, if I was given that, then we would have options. But actually in this example, we really don't even have any options. We have to use the top two triangles. Okay. So back to the yellow one, that one, and we have this one marked. And we also have a right angle there. And the green one, good thing we went with the top two triangles, eh? The green one, that one's marked, and we have that's a right angle. And we already said the right angles were congruent to each other. So with that, I need now either another side or another angle. Look at what they have in common. I'm seeing actually an angle that they share. They both share this top angle, angle A. So I can say, I know we've been using only reflexive property on segments, but you can say an angle is congruent to itself, reflexive property. And then these two triangles are congruent. Triangle AEB is congruent to triangle ADC in the right order. I've got an angle, a side, and an angle. So then finally, what I was trying to prove, BE and DC would be congruent to each other by CP, CT, C. So you guys can work on the worksheet that's about to hand out to you, and make sure that you're using your colored pencils, your highlighters, you're redrawing the pictures. Look for which two to prove congruent to each other. Look for the ones that have the most stuff that is given, and then look at where you're trying to head to. What is it we're trying to prove? Can I use a CP-CTC on these two triangles to help me get there? If not, then try looking for another pair of triangles. So this is Mrs. Rainey, and I am signing off.